Help with trig number 1. It's absolutely imperative that every calculus student be able to calculate the trig values for a given angle of a special angle or a quadrantal angle. Now, we're looking now at the unit circle. Sometimes students don't realize that with the unit circle, there are really only the values in the first quadrant that need to be memorized, and then the second, third, and fourth quadrants will be those same values with the signs changed. For instance, if we take here the pi over 6, and its coordinates are radical 3 over 2 and 1/2 that can be gotten from a special right triangle 30, 60, 90. Every one of these special angles, pi over 6, 5 pi over 6, 7 pi over 6, and 11 pi over 6, have the same coordinates on their points, like radical 3 over 2 for the x and 1/2 for the y. Radical 3, of course they can't exactly be the same because they are in different quadrants, but that's a beginning place. Radical 3 over 2 and 1/2. Now, what you have to do is modify these based on the quadrant that they're in. This is an x-coordinate, and this is a y-coordinate. In the second quadrant, obviously the x is going backwards, and the y's are going up. So the x-coordinate here would be negative. In the third quadrant, the x's are going backwards, and the y's are going backwards, going down. So both of these numbers need to be changed to negative. In the fourth quadrant, the x's are going positive again, and the y's only are negative. Some teachers have made a mnemonic about which trig functions are affected by these changes, and that's all students take classes or all students take calculus, and that can help you remember which trig functions are affected. The sign stays positive because you see the y-coordinate stays positive, and the sign involves only the opposite and hypotenuse. So in the unit circle, if you have any angle that's pi over 6, reference the first quadrant and change the signs accordingly, and you have the cosine and sine, the cosine and sine, the cosine and sine of the angle of interest. Now the same can be done with any multiple of pi over 4. Pi over 4, 3 pi over 4, 5 pi over 4, and 7 pi over 4 have the coordinates radical 2 over 2 because pi over 4 is its own complement. And the pi over 3's, they all have the same coordinates. So if you can fix this in your mind, that you really only have to be familiar with 3 sets of coordinates, and actually there's only 2 because the pi over 6 and pi over 3 are complements, and you can see the x's and y's are just exchanged. The 1/2 is the smaller of the two things, 1/2 and radical 3 over 2. So when you see your reference triangle, you can see which side, the x or the y, is smaller. That's the one that's 1/2. When you have the pi over 3, obviously the y is the smaller one. That's the one that's 1/2. So just a little bit of thought about this can help you to get the trig values of the special angles, pi over 6, pi over 3, pi over 4. Hope this helps a little bit.